Hi, in this video I will answer a question that often gets asked, and the way it is phrased is slightly different, but it boils down to what kind of bicycle should heavy riders, heavy cyclists use so it doesn't break. And I will try to answer it as briefly as possible, with later explaining why I'm recommending what I'm recommending. In this video's description I will put a timeline so you can skip to the parts of interest, not have to watch the entire video. As always, you will have to put up with any background noise and my less than perfect English and my pauses while I think how what I want to say is pronounced in English. For this video we will not need any of these tools. I just I think they're very cool and I feel like a real mechanic when I have these. I'll put them aside now. So first, what kind of bicycle would I recommend for heavy riders? Like over 100 or over 120 kilograms and further on. Get a low budget, very simple bicycle frame without any bells and whistles like hydraulics, shock absorbers, anything. Just get a basic bicycle model. Put some good wheels, good strong wheels with 36 spokes, and make sure that the rear wheel has a Freehub mechanism, not a free wheel. And at least make sure that the front brake is a decent one. Okay, now I'll translate what I just said in plain English. Let's start with the rear wheel with the Freehub mechanism. Here is a wheel with the Freehub mechanism, and this is just the hub, what it looks like. With the Freehub mechanism, how can you know that the wheel is with the Freehub mechanism? Well, the simplest way to determine that is when you are back pedaling or pedaling, this part will move, this front section, along with the sprockets. On a freewheel mechanism, that part doesn't move. It stays in place, only the sprockets move. That's the quickest way to determine. With the free wheel, like this one, this whole set has the bearings on it and the ratchet mechanism, and it's screwed onto the hub. While with free hubs, you just slide the sprockets onto these splines generally. There are also some screwing mechanisms like newest SRAM, but I won't get into too many details. That's the bottom line. Why is this important? When you mount your wheel into the frame, I'll mount it upside down, have the left side closer to you so you can see. This is the important part. When you mount it into the frame and when you put some heavy weight on it, it's best to have bearings be as close to the ends where the mechanism is held on to the frame as possible. You don't want the bearing to be near the middle of the hub, because you will have a large section of unsupported axle, and that will help axle bend and brake more easily. With the freewheel mechanism, this is a freewheel axle. This right hand side bearing is moved closer inwards because this ratcheting mechanism is just screwed on to the hub. So this large section of axle is unsupported, while with freewheels the bearing is underneath here, it's closer to the outer edge, and this ratcheting mechanism moves on top of it. So here's to compare them. The bearing here is further out and here it's closer to the inside. When you're going with the high quality wheels that are durable and capable to take much beating and a lot of weight, you want the rim to be strong, relatively deep, double walled. Not too much, doesn't have to be too much, but it shouldn't be like this one. This one is very thin and this one is much deeper. You can see the difference. This will allow for a lot greater spoke tension, making the wheel effectively a lot stronger. And choose the wheels with 36 spokes. Don't go below 36 spokes, that's my recommendation. I'll explain why that is important. This wheel has 36 spokes, so the whole load is shared by a huge number of spokes, and there is not a long section of rim that is unsupported. This is important for durability, and even in case of spoke breaks, when you have 36 spokes, you can just continue riding to the first shop, while if you have fewer, like 16 or 20, if one spoke breaks, the rim will come so much out of true that it might start scratching on the frame even. So it's not very durable and perhaps not even a very safe option. When you're going with 36 spokes, in my experience, it's best to lace them 4 across. What I mean by that, this spoke marked with red crosses 4 spokes before going into the rim. It crosses this one. This is the first one. That's what people often miss when they are counting the number of crosses. It's the spokes that go in the opposite direction. The first one, then it crosses the second one, the third one, and it goes under the fourth one. It's interlaced beneath it before going into the rim. And why this is important, here we have a hub, and when you have the no crossing radial lacing, the spoke will be like this. So there's not much hub flange material for it to use any sort of leverage to hold the hub in place when the rim is under force trying to move it sideways or whatever it is you're exerting on it. Also, when you have driving or braking torque with disc brakes, this is not a very stable way. This is like 1 across, 2 across, 3 across, and when you come 4 across, it's almost 90-degree angle. So there's the highest amount of hub flange that the spoke can lean against. Same happens to the other side spokes. And this provides good strong leverage, and when it needs to resist any driving torque, the torque is trying to elongate it, which makes it very strong and stable, unlike radial lace spokes where the torque tries to twist the spokes, and it can twist it, but this way it's a lot more difficult, and the spoke is in a lot better. It has a lot easier job. And if you are building a set of high quality wheels that you want to be durable and last even for heavy riders, I recommend to go with Shimano hubs of some mid-level are very durable, like Shimano Deore or Tiagra for road bicycle hubs. No need to go any more expensive, you'll get lower weight but not much more durability. And choose spokes that are swagged in the middle, double butted or swagged spokes. They have thinned down midsection, not by grinding it, but by rolling it in the factory when they are made. So the thinned down midsection acts as sort of a shock absorber that releases and reduces some load from the critical sides of from the critical points of a spoke that are near the elbow and where the nipple threads are. So it helps reduce load on those parts by elongating a bit more easily, acting as a sort of a spring effectively. There are also spokes that are marketed as triple butted. I will put a link to the product in this video's description. There's a model made by DT Swiss called Alpine 3, and it has 2.3 millimeter width at the elbow diameter, so it's even thicker at the elbow, and 2 millimeters on the other end, while this midsection is 1.8. These spokes are the most durable that I could find, and they are made with high quality of good materials with very little factory defects, and that construction, the design, makes them to be very long lasting and very durable. So they cost about $1 or even more a piece. So for a 36 spoked wheel you would need, at least for the rear, which takes a lot more load, you would need $36 or more for just spokes. But you build that wheel only once and it lasts for decades. If you service the hub, if you go with Shimano cup and cone bearing hub, you need to service those bearings at least once a year or every 5,000 kilometers or like 4,000 miles, maybe even a a bit less depending on your riding conditions, and with that kind of service they can last for 10 years or more. And now, why did I recommend a cheaper bicycle, more simple? I'll try to show it using this. Okay, here we have a bicycle frame, and you can see like two triangles. This one has this section, but that's necessary in order to hold the fork in place and make it more rigid and stable. But the bottom line is that this structure allows for the strongest and stiffest possible frame with the lightest and thinnest possible tubes used. Here we have one tube. This is a seat post, low-end cheap seat post. And just like with frame tubes, it has two important dimensions. One is the outer diameter. Here it is thicker in the top section than it is in this lower end. And wall thickness. This is what I mean by wall thickness. This diameter or width or thickness. And a way to make a frame be strong and light, it helps when you use wider, larger diameter tubing. If you make this be twice as wide, you would get the effective strength when you put it in a frame to be about 8 times greater, because the strength and stiffness of a tube rises exponentially to the 3rd degree. I think, hope some mechanical engineers will correct me, but roughly speaking, something like that. It rises exponentially as the diameter increases, and as you make the walls thinner, the strength and stiffness does not diminish that significantly. You get more strength by making the diameter larger than you lose it by making the walls thinner. So that is used to make a frame be very strong and stiff enough without being too heavy. However, with high-end frames, they try to make it, manufacturers try to make them be as light as possible because that is what sells. So some of the tricks that they use is to keep the tubes be a bit wider and have a bit thicker walls near the ends where they are connected, joined together, because those areas are of high stress, while they make the midsection be with thinner walls. That allows them to keep the frame strong enough and stiff enough without being very heavy, making it light. However, the amount of engineering during the design and the amount of testing is not always very good, and frames that are super light often end up being not very durable if you ride over bumps, which I think is normal for bicycles, and if you are very heavy and very strong, so there is a higher probability that the frame will crack somewhere. While with the low-end, cheap, simple frames, there's not too much thinking. They just make the tubes be wide enough and make sure the walls are thick enough for them to have the minimal amount of returns, the minimal amount of defect. It can be 1 kilogram heavier, but we want it to be durable and to forget about it. So if you are a heavy rider, especially if you're on a budget, a cheaper low-end frame might be a safer bet than going high-end. What about road bicycles? That's what I also get asked. Well, there's no reason for heavy riders to not ride road bicycles, as long as you make strong wheels like I explained earlier. Go with 36 spokes, saving a few grams, getting more air or something. I'm not sure, especially for people who are very overweight. Like there are other ways to. If you have over 100 kilograms, having 100 more grams on your wheels will not make that much of a difference unless you are competing or something. So it's better to err on the side of caution and make sure you have a worry-free ride, in my opinion. And so get a road bicycle with good wheels and go with some perhaps lower end frames that are more over-engineered, stronger. Maybe some good examples are given in my last published article about which road bicycle should I buy. I will put a link to that article in this video's description. I think those are quite good candidates for something like this. And can aluminium frames, that's what I also got asked. Can I ride the aluminium frame if I'm over 150 kilograms? Inherently, frame materials don't make a difference. You can make a frame that is durable, strong out of any material, and you can make a frame that is weak and bad out of any material. So steel frame is not always stronger than aluminium or carbon fiber just because it is steel. It can be stronger or it can be weaker depending on these things that I explained. I will put also a link to my article explaining bicycle frame materials, all their pros and cons, about the most popular materials used. But here just a short version. Any kind of metal, titanium, steel, aluminium, is generally okay, because even if it starts cracking, even if it turns out the frame is not strong enough for you, for metal frames the cracks will appear on the outside, usually near the joints, depending on how welds are made. But that's where they usually appear, like a thin hairline cracks, sometimes even on other sections, but you will notice them. With forks they usually start at the rear end, here. You will notice them, you will have the time to stop and see if you can fix the frame or replace it or anything. But with carbon fiber, they are not inherently less durable than steel or aluminium or titanium. And the carbon fiber is a material that allows you to create a frame that is very light, very stiff, very strong, and you can even play with the way the plies are placed to make it be what cannot be made so easily with other materials, to be vertically compliant, so it sort of even absorbs some road buzz or bumps, and to be stiff in the direction where you put your force, like trying to twist the bar when you're riding out of the saddle or pedaling hard and so on. So it's a good material, but the problem is that when it fails, it does not give any signs that are visible on the outside very often. It just gets weaker and weaker. There's delamination in the fibers and other problems. And then that's one problem. You will not see it when it starts to break. And the other problem is when it breaks, the failure is, like I say, catastrophical and complete and sudden. So you don't just have the tube collapse, you have it like go to pieces, smashed, and that's not very safe and very pleasant if it happens on a downhill or when you're riding in traffic or something like that. While inspecting carbon fiber frames with an ultrasonic scanner or X-ray is very expensive, and the factories don't do that, as far as I know, they don't do that for every model before it hits the shop floors. So even when you're buying a new frame, it might be a good idea to scan it, and perhaps even once a year if you ride a lot, or if you have some paint damage, or if there are any metal parts in the frame, so there's galvanic corrosion between carbon fiber and aluminium usually, or steel parts. So that adds costs, and there is that risk. So for heavy riders, for that reason, I might not recommend carbon fiber bicycles as a good idea. If you make a carbon fiber frame that weighs as much as an aluminium frame, that frame will be super strong, like 5 times stronger, or super stiff, and you will have a lot of margin of error. Even if there's some delamination problems, it will not break down, but nobody does that. They want to make the frames light so that sells well, and that is the problem. So nothing against carbon fiber, but I hope I've explained why I would not recommend to a heavy friend to buy a carbon fiber frame. And did I forget to mention something? Okay, the brakes. Decent quality brakes are a good idea even for riders who are not heavy. And for that, I would recommend Shimano. That's the easiest to find, and I will use that as a reference. There are other manufacturers who make comparable models depending on which budget you're going with. They have better or worse. Shimano mid-range like Deore or for road bicycles Tiagra are pretty good brakes with good brake pads like Cool Stop Salmon and Aluminium rims. They will provide good stopping even in the wet, even in the mud, unless the wheel is bathing all the time in the mud. You don't just go through one puddle, but you're riding in muddy conditions. For that, okay, these brakes are probably a better idea, but otherwise, I don't think that if you are a heavy rider, you must use these brakes. You can use rim brakes. I've used rim brakes with a heavily loaded bicycle, hauling kids and everything. I could stop with no problem. So after over 30 years of cycling, most of my bicycles have been with rim brakes, and I haven't had any problems with properly adjusted rim brakes of decent quality. The same goes for disc brakes. I rode some bicycles with very poor quality disc brakes and that were awful, and also rode some with high quality, and that's good, but so are the rim brakes, and I don't think that's a must, again, in my opinion and experience. So just get decent quality parts, especially if you're heavy. Invest in good quality wheels, but this goes even for riders who are not heavy. You want something durable and to forget about it. You make it once and you just ride. That's my recommendation and my preference. And so I hope this video has helped at least someone more than it has confused you. Thank you for watching, and cheers.